Before you ever begin testing MPO connectivity, there are a few key things to always be aware of. The first is understanding whether you're working with single mode or multi-mode connections. There's a couple easy ways that you can tell this. Here's an example of a single mode connector. It'll always have the yellow jacketing on it. In addition, the single mode MPO connector will typically have this green connector color on the end of it as well. You'll oftentimes see single mode connectors will also be yellow. Now both of these indicate single mode by the yellow jacket and either the yellow or the green link. For multi-mode, you'll typically see that this is aqua. This will be both an aqua jacket and an aqua color. The other thing that you can confirm whether you're working with single mode or multi-mode is whether the connector has an angle on the ferrule or not. You'll notice that the single mode one, I'll use the no pin version, if you look at the side angle of that connector, it has a slight angle to it, whereas the multi-mode one is flat. That's a key indicator that this is single mode and this is multi-mode. So you have the angle and you have the color of the jacketing and the connector. The next thing to look at is whether you're dealing with pins or your connector has pins or does not have pins. Now every MPO connection requires an interconnection between a pinned and a non-pinned interface. Here is a close-up of the pinned connector and the non-pinned connector. These two will interface together. If I have two non-pinned connectors or two pinned connectors, they will not interface together. Then you need the pinned and the non-pinned connections. The next thing to look at with an MPO interface is this key at the top of the connector. Every MPO connector has that key, and that determines part of the polarity of the interconnection between the two connectors. Now with MPO connectors, they'll always connect through this very simple, large adapter block. Now with a single fiber connector, you're dealing with a precision alignment sleeve and such. With MPO connectors, they're very simple, but you'll notice that there is a notch in there that indicates the direction of the key. Now this is a common configuration here where one side has the key down, but if I turn it over, the other side has the key up. So when these two are mated, one is key up and the other is key down. That determines the polarity. You also have adapters. Here's one example of one that has key down and key up. Key up to key up. That determines the polarity in a different manner for this one. The final thing that you always want to deal with is making sure that you have a clean connection. Now we talk about inspect before you connect a lot, and there are a number of tools that you can use to do that. Here's the most popular one. This is the FiberCheck Sidewinder, which has the interface on the end that can plug right into the bulkhead adapter. This is an APC interface right here for inspecting single mode. I can change this out to inspect the multi-mode as well. Another popular option is to use our P5000i probe with a ribbon tip on the end of it. Here's an example of the APC one along with the flat one. So this would be used for inspecting single mode. This would be used for inspecting multi-mode. It just attaches directly onto the probe itself. And so those are a few key things to be aware of whenever you're working with MPO connectivity. Before ever working with MPO connectivity and proceeding to testing, there are a few key things that are important to be aware of. The first is understanding whether you're working with single mode or multi-mode MPO links. There's a couple easy ways to check what you're working with. The first is the color of the jacketing itself. On the right here is the yellow jacketing, which indicates that you're working with single mode MPO fiber. Here on the left is the aqua jacketing, which indicates you're working with multi-mode. The next is the color of the connector itself. Here on this multi-mode connector, I have the aqua color that matches the jacket. On the single mode connector, I have this green color that indicates that it's APC. You'll oftentimes see single mode fiber with a yellow connector interface as well. Both of these indicate that you're working with single mode fiber. The third way that you can tell you're working with single mode or multi-mode fiber is by the angle on the ferrule interface itself. At the end of the fiber, if I look at this single mode one and the multi-mode one, when I turn them sideways, you can see that the single mode one has a slight angle to it, which means it's APC, whereas the multi-mode one has a flat end face to it, indicating that it's multi-mode. The next thing that you want to be aware of is understanding whether your connector has pins or does not have pins. Now, every MPO interface connection requires one end to have pins and the other end to not have pins. Now, the pins are aligned with the sockets through a bulkhead adapter. If you try to mate pins to pins, it will not interface. If you try to mate a non-pinned to a non-pinned, it will not get a good connection, and there could be increased loss and slipping of the connectors in there. So that does not work as well. So you always need to make sure that one side has pins, the other does not. This applies to both single mode and multi-mode. The final thing to be aware of has to do with this key on the top of the connector itself. Now, this determines part of the polarity approach that the various MPO connectors links that we'll use. You can see here that there's a key on the top. This interfaces with the bulkhead adapter. If I show you here from the front view, there's a key at the bottom of this bulkhead adapter. But if I turn it around, the key is at the top on this side. So when I plug this in, this one goes key up, this one goes key down, and that's the particular polarity type. Now, there's other adapters oftentimes that will indicate key down to key down, as shown in this example. The final thing that we want to confirm is making sure that our connectors are always clean. There's a couple of ways that you can do that with different probe microscopes and such. The most popular one is the FiberCheck Sidewinder. It has an interface tip right here that can plug directly into the bulkhead adapter, and you can proceed with automatic focusing, testing, and alignment of everything. The other way that you could do is using a P5000i probe microscope and just changing out the tip to inspecting the ribbon connector. Here's an example of an APC finish tip that is used for inspecting single mode. Here's one with a flat tip that would be used for inspecting multi-mode. So these, you could manually scroll across each one, get it in focus, and check each individual fiber. And of course, you'll want to make sure that you keep those interfaces clean. There are purpose-built cleaning tools by various manufacturers that can be used to clean all of the fibers on the MPO interface. So those are a few key things that you always want to be aware of and have covered before you proceed to any testing of MPO connectivity. Thanks for watching.
We did all this?
Oh, that's good.
Works nicely, huh? Go.
This video provides an overview of our HD4i video display used in conjunction with the P5000i probe. I have it right now in a hands-free carrier case. This is a popular way to use it in a field environment. This carrier strap here allows you to wear it around your neck and walk around freely. You can also use this to hang it on the back of a patch panel on the door of a cabinet or such. And it also has various storage compartments for your probe microscope, for cleaning tools, for inspection tips, a visual fault locator, whatever you need. Everything that you need is available in this hands-free carrier case. But now I'd like to walk through some of the various controls on the device itself. I'm going to go ahead and take this out of the case. All right, now that I have the device removed from the case, we can go ahead and begin interfacing with it. The first thing that I want to do is turn the device around, remove the stylus. I'll use that to interface with the touchscreen, and activate this kickstand so that I can set it down on the table. A couple of things here. On the side, you'll see there is a power input. This is where I can plug the device in and give it power or charge the device. It actually has a rechargeable lithium-ion battery in it. And also there are a couple of USB inputs. There's a micro USB input that allows you to connect to your PC for configuration of advanced settings, and also two standard USB inputs, which are purely used for connecting other test instruments. There are no capabilities for storing external data or anything. It's purely just to interface with the probe microscope. So now let's take a look at this controls here. We have a home screen. No matter what application you're in, when you press the home screen, the home button, it'll return back to this view that we're at now. The next is this menu key, and that, when you press it, it opens up various menu options depending on the function that you're in right now. So say, for example, I'm in More. If I select More, I can press the Select key or touch the screen, and it gives me things like the ability to recall the image, configure system settings, input user info, and such. Now, I can either return back by pressing the Home key or pressing this Return Back key. There's also a series of navigation keys to go up, down, left, or right. There's a Save button here, and then there's this Input Select key that allows me to toggle between multiple applications. Let's say I had two probes plugged in or something like that. And then finally, there's your Power button. But let's go ahead and activate inspection. I can either touch the screen or I can select it from here. I'm going to go ahead and just touch the screen, and that's opening up the fiber inspection application. And now I'll plug in a fiber, and here I'm at a live view. On my P5000i probe, I can get it in focus here. I can press this button to toggle magnification, but I want to proceed forward to begin my testing. But before I do that, I need to make sure that I have my right acceptance criteria in place. And to do that, I'll press the menu key, and there are a couple of options available. And in the next video, we'll take a closer look at how to use these configurations to set up your test properly. In this video, we're taking a closer look at the various menu options available on the HD4i. From the home screen, if I press the menu key and I select More, it'll be highlighted here in this color. I can either touch the screen or select it there. It gives me a couple different options for recalling images, reviewing data and such if I had a power meter plugged in, system settings. Here, if I select user info, I can fill in information about my company, my address, all of that. And then, of course, if I wanted to connect to a PC later on, this is where I could do that. I'm going to go back, though, and enter into my inspection application because there's additional menu options available when I'm inspecting. At this point, when I press the menu key, I can adjust things like brightness and such, but I also want to go into my profile and my tip. Now, these are my acceptance criteria for how I want to inspect according to any pass-fail criteria. The first thing I want to do is go into Select Profile, and it'll give me a list of a number of different acceptance criteria. I'm currently selected on single mode UPC, and it gives me even an industry standard next to that. These all come preloaded on the device, and I can also create custom configurations by connecting this to a PC and then loading these onto the device. But I want to stick with my single mode UPC criteria there, so I'll press back. Now I want to go into tip and just make sure that I have the right tip selected. Right now I'm using the most standard configuration. This is a standard tip with a BAP1 optical lens attached to it. So that's straightforward. There's other long reach tips and things that are available, and if I was using one of those, I would select that one, but I don't need to do that. I'm going to stick with what I have and select that. And now I'm ready to proceed forward with my test. Now that I have all my acceptance criteria set up, I'm ready to go ahead and proceed forward with testing. Now you can see on the screen here that the image is in fairly good focus. I'm going to get that out of focus for a bit, and you can see that the focus quality meter goes down and it indicates a red color, which tells me that's not in a good enough state to be able to be running a test. So I'll get that in focus here, and I can proceed forward. All I need to do is press this button here to run the test, and that'll proceed forward to running the inspection based off of the acceptance criteria that I set in place. This gives me a pass. It shows me all 4 zones here based off of the acceptance criteria, and it tells me that each one of those has passed. Now from here, I can go ahead and save that. I just press my save key. And I've set it up to a place called verify before save. So let's say that I wanted to change this. I could at least take a look at this and review it. You can also configure this so that it will automatically save it. But right now, it always will save it to a base name, which I've set up as fiber, and then increment it accordingly. This is the 3rd one, so I'll go ahead and press OK. And that proceeds forward with the test. And I've got this one saved now on file. Now, let's say I wanted to review this. I could go back, go into my More, choose Recall Image, and there is Fiber 3. If I wanted to check that, I would say View, and now I can view that stored result. And that's running a test and saving using the HD4i and P5000i. In this video, we're going to take a look at the FiberCheck Pro software program and how it can be used for configuring your various test instruments. Now, FiberCheck Pro can be used for basic inspection, analysis, and report generation for fiber inspection, but the other advantage is that it can be used for configuring all of your instruments. In this video, I'll walk through some basic configuration you can do on the P5000i probe microscope, as well as an HD4i handheld display. The first thing I want to do with the P5000i, and in this scenario, is there are a series of different tip settings and such that are available on the P5000i. You can see here in this menu that I can view all those, as well as the different profiles. But over here, if I choose Setup P5000i, it'll take me to a menu, and on the left is a series of optical settings. When I select that, it tells me on the right that I have 4 different optical settings available on the device. Standard tips with the BAP1 lens, and a couple various ribbon tips and such. Right now I'm using this standard tip, but in some applications like in military and aerospace applications, there's different lenses that are used, such as here is an example of an A-Rink guide with a BAP lens that's used. That requires a different optical setting. So when I go into FiberCheck Pro, on the available side here on the left is a series of several other optical settings. If I choose Mil Aero guides with the BAP3 lens and select Add, that now added that optical setting to my device. I choose OK, and now my device is ready to go. It defaulted to that guide, that tip setting right here, so that's ready to go. What I want to do now is plug in my HD4i display, and you'll notice that the screen of the HD4i just changed to a USB icon, and it tells me information about what's on this device. I have 3 inspection reports that are saved, and that's it. But what I want to do is go into and set up my pass-fail profiles in here. So if I choose Setup HD4i, there's a number of options available on the left. Device information, device settings. I can even update my firmware in here. This is currently up to date. I want to go into analysis profiles. And you can see here on the right, just like the P5000i probe with the tip settings, there's a series of different analysis profiles that are available. But what I want to do is I want to choose one that is specifically for the application that I'm looking for with the mill arrow guides. And so in this one here, I'm going to choose oftentimes the single mode UPC edition 2.0, which is the latest update, or whatever configuration that you want. And I want to copy that over. Now that copied that to the device, and I can choose OK. Once that's done, now I have my HD4i updated with the inspection profile criteria that I wanted, along with my P5000i, which is updated with the new optical setting that I want to use for my specific lens and alignment guide for the aerospace applications. Now I'm going to go ahead and attach those devices, and we'll show you what it looks like on the screen. In this video, we're going to take a look at how to set up your HD4i and P5000i to inspect unique applications like military and aerospace connectors. In this scenario, we're going to be looking at the criteria for an A-Rink connector using the BAP3 lens. Now, in the previous video, we showed how the FiberCheck Pro software can be used to add the profile information into the HD4i and configure the tip setting for your P5000i. Now let's go ahead and make sure that those new criteria are activated. I've just activated the probe. I select menu key and I choose profile. Now it defaults to the last one which was shown, activated, which was multi-mode, IEC 61300. And now in many aerospace applications, multi-mode is what's used. But since I added that new single mode UPC edition 2, I want to choose that one. So now that that's selected, I can go into my tip setting, choose that, and now you'll notice there's a new option available, the mill arrow guides with BAP3. I want to navigate down to that and select it. And now I'm ready to go. Now I've chosen my new profile, which has been added to the device. I've chosen my new tip setting, which has been added to the probe. And I can proceed forward with testing using my corresponding A-Rink guide with the BAP3 lens and proceed forward to testing each individual fiber.
In this video, we're going to give an overview of the OLTS 85P, and then in subsequent videos, we'll talk about how to set it up to perform a loss length test, how to set a reference, how to actually perform a test, and how to generate reports. So this is the first of a series of 5 videos that you'll see. So the OLTS 85 is part of our Smart Class fiber family of products, which all have the same basic form and shape to them. So if you look at it from the side, you'll see that there are connections at the bottom where you can plug in power. You have USB ports for connecting things like USB sticks or our P5000i digital inspection probe that we'll show in later videos, as well as a micro USB for taking test results off the instrument to reporting software. On the back of it, there is a kickstand, and there is also a stylus so that if you're typing on the screen, it's sometimes easier to use the stylus. At the top of the instrument, and you'll notice it's labeled as a local, and you'll see in later videos we do have a remote as well. We have a cap that if we open up, we see the various connections that are available for the OLTS 85. And we have a single mode source, we have a multi-mode source, and we have a shared receiver. You can buy this product with just single mode or just with multi-mode. This is our quad version. And you notice that the shared receive port has thumb screws so that it can be replaced from an LC to different types of connectors based on the system that you're testing. We also have a patch cord microscope on the left-hand side. It is available with or without a patch cord microscope. We strongly recommend the PCM be used and purchased. And then at the top, in this particular case, we've come with a duplex LC adapter for inspecting our LC fibers. So that's physically how the unit is set up. And then when we look at it from how you actually navigate and use it, we have a home screen to start with. And we do have this quarter VGA touchscreen as well as the keypad. And you can really navigate by using the keypad or by touching the screen or a combination of both. And most people we find tend to use a combination of both as they see fit. So From the keypads, we have the home button will always take you back to this home screen. We have a menu button, which pops up a menu in certain situations, and you can also tap the screen to get that menu button. And we have the back that you already see me using that, so if I type something and I want to go back, I can use the back button. We have a workflow button that we'll cover in later videos that takes you from application to application. We have a save button, and there's power, and there's keypad, etc. But you can also do a lot of this by tapping on the screen. So the home screen I'll come back to in a second. We have at the bottom left, you'll see there's a settings uh, icon. And when you go into that, you can turn on Wi-Fi, Bluetooth, which are through USB dongles that we don't have connected right now. You can adjust the brightness of the screen, and you have a help, which will show you your software revision that's installed, and you have a more button. And the more button has all your administrative functions like your auto off, your screensaver, your language, your date and time, etc. to it. Then in the center here on the left-hand side, we have a management icon, and this is where you set up a project. And you'll notice right now we have the project at the top called Viavi Rocks. We can come into the project screen and we can remove, we can add, we can copy, and we can set active various projects. So on this particular instrument, I just have a default project, and I have the Viavi Rocks project, which is the one that we're going to be working in, and you can see that it's already active. Then we get into our home screen. This is our test tool home screen, and you see that we have, in this case, 6 applications installed. So there's a loss length application, which is where we will focus in our future videos. And we have a loss application, which is for doing a loopback test. We have a power meter, we have a source, we have the probe, which is the P5000i, plugged in to inspect fiber end faces, and we have the patch cord microscope, which is using this here. And again, we'll go through all these in later videos. And that's it for this video. We will also put up on the screen resources that are available to people to go to get things like user manuals, etc. This is our second video of our OLTS 85 series, and in this video we're going to talk about and show you how to set up for a loss length test. The loss length test is sometimes called a Tier 1 certification test or a basic certification test. And normally a loss length test is done by using 2 instruments. So one is the local and the other one is the remote. And you'll notice that we have a screen on both the local and remote, which is you're going to see comes in really handy so that you can inspect all your fibers at both the local and the remote side of things. But all your setup for a loss length test is done through the local unit and then it pushes the configuration to the remote when you connect them together. So when I go into my loss length application, I then press the menu key. Within here you can see a couple things, and I'm going to do this on the remote as well, is that number one, you can see that you have a device type. So you can change the personality from being a local to a remote. In this case, I've got a local here, I've got a remote here. You always need to have a local and remote for doing this test. If they're both set to local, they won't communicate. Both set to remote, you won't be able to actually do any configuration of it. Within the loss length application, we do, again on the local unit, have a more button, and it gives you some different options. So it can let you look at your test results that are stored, your cables. So there's a cable database that you can manage here, whether you want to be in feet or meters, whether the sound is on or off, and that you'll hear beeping as we connect things together in later videos. The negative loss warning, which I like to have on, as well as the unsaved result warning, which prevents you from exiting screens without having saved the results. So I like to leave all those 3 things on. So once you've got those little administrative things looked after, you can come in and you can go into your test configuration. And in this case, I've got a multi-mode fiber generic configuration. I've got my default configuration. And through my menu, just like I had with projects, I can remove, add, copy, or set active these different test configurations. In this case, I've already got the one set up that I want, so I'm going to just go in and look at it, which this is my multi-mode fiber generic application. It tells me when it was created. It's a multi-mode test with a remote unit. It's using the TIA 568.3 test limit, and it's a generic multi-mode fiber with OM4, and I'm not doing a bidirectional test, but I do have a 1-chord reference. A lot of these settings, if you're not familiar with them, we have different application notes and white papers that can help explain these to you further. The one that I will go into a little bit here is your test limit. So when you go into your test limit, you have many different choices as to what you can set. And if you're in one of the TIA or IEC limits that is calculated, it's asking for the limit for your length, the number of connections you have, loss per connection, number of splices, loss per splice, and your dB per kilometer loss at 850 and at 1300 nanometers. So with all that set up, I make sure that it's set active, and at this point I'm ready to perform my set reference, which is our next video, and then I proceed on to testing. In this video of the OLTS 85, we're going to demonstrate how to set a reference. And you recall, as we set up our Tier 1 test, we set it up for a one-chord reference. And a one-chord reference is the standard way of setting a reference when you're testing links. It's recommended by all the standards. It's recommended by all the cabling vendors to use a one-chord reference. So that's what we're going to demonstrate. You can do a 2 or a 3-chord reference, but the one-chord reference is the preferred method and is the one that is actually has a lot of confusion around it. So what I've already done is I've inspected and, if necessary, cleaned my FC connectors for my multi-mode launch cords, both on my local and remote unit. And I then have the other end of this cord, and it may be a little bit tricky to see this, but this is one cord, and I put the other end into my patch cord microscope. And then I use my workflow button to quickly get to there so that I can see that fiber. And I can see that it looks really nice, so I take it, and this is from my remote unit, and I'm going to plug that into the receiver of my local unit. So it's called a one-chord reference because you have one cord between a transmitter and receiver. So here's my transmitter from my remote. It's connected to the receiver of my local. Now I'm going to take my other fiber, which is the cord coming off of my source of my local unit. I'm going to plug it into the patch cord microscope. I'm going to press my workflow button, and I am going to then look at that fiber end face and make sure that it's clean as well. In this case, I'm not doing any pass-fail analysis because I'm not so much concerned with that. I want to visually make sure that my test cords are good. My pass-fail analysis is really important when I get to testing a system. So again, one cord between that transmitter and this receiver. I plug that in here. And you hear the units beep at each other to indicate that they're connected. I push my workflow button twice to return me back to my loss length application. And I can see that they're connected together by the icon, both on the local and on the remote unit, that shows the two units talking to each other. And I have this little purple icon, which is my set reference icon. And that's because I've never set a reference with these units before. If I was to press my menu button, I would have the set reference would be there as well, but I don't need to do that. I can just do everything from the screen. So either on the remote or on the local, I press my set reference button. It tells me that it's referencing. It takes a couple seconds, and then it's going to say set reference success. And now you notice my set reference icon changed to a test icon. So now I'm going to disconnect from my receiver only. This is critically important that you never disconnect now from your transmitter, otherwise you destroy your reference and you have to start all over again. So I take that fiber, I put it into my patch cord microscope, I take this fiber off of my receiver, and I connect it into the patch cord microscope of the remote unit. So what I have now is I have my source fiber on my remote, connected from the transmit port to the patch cord microscope so I can look at it. And it also provides a nice safe place to keep this test cord. Test cords are expensive, so you want to have a safe place to keep them, and you want to have the easy way to inspect them, which is why we have the patch cord microscope. So what I have to do now is I have to add on my receive fibers. So I take my receive fiber. I'll do this from the local or from the remote side first, just because it's closer to me. I put that fiber in, I press my workflow button. I see that it's got a great big piece of junk on it, so I take it out, I give it a quick clean, I put it back in again, I focus it up, looks good, so I'm going to connect that up to my receiver. Then I'm going to take the other end and I'm going to put it into my patch cord microscope. I'll come back to that in a second, but now I'm going to do the same thing on my local unit. I'm going to take my second test cord, I'm going to put it into my patch cord microscope, I'm going to press my workflow button, I'm going to focus in a little bit on it. I see that it looks nice and clean. Didn't have to clean this one, which is nice. So I take that off of there, I plug it into my receive port, and I take this and I plug it into my patch cord microscope. So now you can see that what I've got is I've got my two cords, a receive cord and a launch cord. They're color coded, so I've got the black and the red, and they're both plugged into the patch cord microscope. And what this allows me to do is to look at that one fiber. It looks nice. I slide across with my duplex LC, focus in again a little bit, and see that that fiber is clean as well. I do the same thing on my local unit, where I get focused in, look good, slide over to the other one, look at it, and it's kind of dirty, right? So that I know that I got to clean. So I pull off that red fiber, give it a quick clean, plug it back in, and it's fine. Both of them look good. So I've now set my reference, and there's one last step that often gets overlooked. So I'm going to get back to my loss length application on both my local and remote. I know all my fibers are clean. I'm going to take a good quality coupler. I'm going to take my test cords. I'm going to connect up through the coupler. So this is called a reference verification. It's an important step, and I just perform an auto test with nothing but my test cords and a coupler. And I do that, wait until they connect up, you hear them beep at each other, and I press this auto test button. I'm doing this from the local, but I could do it from the remote as well. It does an auto test. It passes, but what I really want to look for is my loss values. And for multi-mode, I should be below, multi-mode and single mode slightly different, but this is where you want to have losses that are quite low in order to say that your test cords are good and that your reference was successfully set. So this is my summary results screen, and I can drill into the details, and I can look at each fiber, and I can see how much loss I have on each fiber. And once I've done that, I have set my reference, and now I'm ready to go out and start testing. This is the fourth in our series of videos on the OLTS 85, and in this video we're going to actually perform a Tier 1 test. So we've gone through and set up for a Tier 1 or loss length test, and we've then done a set reference, which was a one chord set reference. And now we're ready to test. So what you can see here is that I've got my local unit here. The remote unit has gone to the far end of the link that I need to test. And I've got my cords, my launch cord and my receive cord are plugged into my patch cord microscope so that I can check them really quick and really easily before I connect up to test. So by pushing the workflow button, I'm able to go to my patch cord microscope. I'm able to focus in. I'm able to slide over to the other fiber and focus in on it as well. And in this case, I don't do a pass-fail test on my patch cord, on my test cords. Then what I do is I push the workflow button one more time, and that takes me through to my P5000i, which I have here with a long reach LC tip on it, because I need to inspect inside of this cassette the LC ports. One thing about the patch cord microscope, and we have other videos talking about fiber inspection that you can get more detail on this, is that I have to go into my profile and I've set it up to be a multi-mode according to the IEC standard. And I also need to go in and I need to select my tip. And in this case, I'm actually using a long reach tip, so I'm going to change that to long reach. And that just makes sure that your microscope is set up properly to give the correct illumination and the correct pass-fail. So I take this, I go to one of my ports, I focus in, and it's always it can be fun sometimes to find the fiber. So I get until I've got a nice, good, strong focus on that, and then I press my pass-fail test button on the probe itself. Don't need to touch the instrument at all. I can do everything from the probe. So it runs the pass-fail on the for the multi-mode IEC. Everything passes. I press my save button. It gives me that I'm on fiber ID 2. Yeah, that's what I want to do. I save it. And then I push my test button again. It changes me back to a live view. I plug into the B side. I then get my focus to be pretty good. I press my pass fail button again. It does its analysis of the fiber end face. It comes back, quite sure it's going to pass because it looks quite nice. Gives a pass. I save that again. And I'm going to save that on the same fiber ID number 2. So I save. And then I can escape out of that. I go back to my loss length test. So I've now inspected my patch cords, my test cords through my patch cord microscope. I've inspected my system that I'm going to test. I plug in my transmit lead. Meanwhile, my partner at the far end has done the exact same thing that I just did while I'm doing it, because he's got a screen, he's got a patch cord microscope and a P5000i. I plug in my test cords into my link that I'm going to test. It says that it's connected. I press the test button. It performs its loss length test, does the pass-fail analysis according to the settings for the limit that I had. And in this case, we see that it failed, which is fine. You know, sometimes tests fail. So I had too much loss from the remote to the local at 850 nanometers. At 1300, everything was okay. So in this case, my limit was 1.53 dB, and I had 1.66, so that's why it failed. And in this case, I would then need to look into this and figure out why it's failed. If I want to, I can save my result, even though it has failed. And in this case, I want to be on Fiber ID 2 as well. So I save, and then I can correct this and save another result if I need to. In this video, we're going to show how to actually perform a loss length test. And so we've gone through, we've set up for our loss length test, we've done a set reference, the one chord reference. And once we finished the one chord reference, we made sure that we connected everything up to the patch cord microscope. So I've got my transmit fiber, which is red boot, and I've got my receive fiber, which is the black boot, and they're connected up and they're connected to the patch cord microscope so I can quickly check them. You notice that I just have the local unit here. That's because the remote unit has gone to the far end of the link that we're going to test, and my colleague there is going to be doing the exact same things that I do in terms of inspecting and connecting up to test. So first thing that we do is we push the workflow button. We get to the patch cord microscope. We inspect one test cord. We slide that over. We give it a little bit of focus in, and we inspect the other patch cord, test cord, and then we push that button again. So we've made sure that our test cords are good. Now I'm going to use my P5000i probe, and I'm going to come to the system that I'm going to test, and I'm going to focus in. Now, one of the things that I haven't shown that I maybe should show quickly is that I have to set my profile up for my pass-fail analysis to the multi-mode using the IEC standard, and I also have to set my tip up, and in this case I'm using a long reach tip, so I've set all that up. We have other videos on fiber inspection that cover this in a bit more detail. So I get in, I get connected, I get a good focus, I push the test button on my probe, it runs the test to the IC standard, and I'm pretty sure that's going to pass because it looks pretty good, and it passed. So I hit the save button. I'm on Fiber ID number 4. I hit save again to save that patch cord microscope. Back onto the probe, I push my button again to go live. I plugged into the B side of the connector. I get that to get a nice focus. I push my pass fail button or test button on the probe itself. Notice I don't have to keep touching the tester itself. I'm able to do all this from the P5000i probe. That passed. I hit save. I actually still want to save this to Fiber ID number 4. So I get to Fiber ID 4. I save that again. Now that that's done, I press my button again. I get back to my loss length application. I know that all my fibers are good, and meanwhile my colleague's been doing the same thing, and he may be a little quicker than I am, so he may already be all connected up. But I'm going to be able to tell because as soon as I plug my test cords in to my system that I'm testing, provided that it beeps at me, I'll know that I've connected up. So he's all connected up at the far end. I can tell that by my test icon went purple. I hit my test button. It says that it's testing. Does the loss length test, compares it to the limit, both for length and for loss. And it shows that everything passed. So I had 1.24 dB of loss. I've got a 12 meter link here. My 1300 has got the loss of 1.17 dB. And if I want to view details of that, I can press in here and I can see that the fiber number 1 had 0.85, fiber number 2 had 1.24 at 850. At 1300, I can see what my losses are there. I can see my length as well. And then I press my save button. And I'm going to again go on to Fiber ID number 4, and I'm going to go ahead and I'm going to save that result. And then I unplug from that I've tested. I put these back into my patch cord microscope, and because now I'm going to move to the next pair of fibers. So I just cycle my way through all the fibers using that whole process of proper inspection, documenting the end faces, making sure my test cords are good. Really, with the right tools, it doesn't take long to do things properly. Get through all my testing, and then the last thing that I'm going to have to do once I'm done this job is do a report, which is we'll show you in our last video. So this is the fifth and last video in our series for the OLTS, and this is where we're going to be generating reports. At Viavi, we really give you some different options as to what you can do to get to a report. And we have just some basic reporting functionality, which I'll show you that using our software called FiberCheck Pro. Then which will generate PDF reports or HTML reports. Then we have what we would call test data management, and that's using software called JReporter that lets you bring in your test data and then lets you filter, sort, change some administrative things like users or labels if you need to, and then you can either just send that software package off or you can generate PDF from that. The third is a full workflow that we have called Certify that lets you create a project in the cloud, send that configuration down through a mobile app to the instrument, and then as you perform tests, your test results go back up to the cloud automatically based on the connectivity that you have from the instrument to the mobile and the mobile to the cloud. We're not going to focus on that last part here, the workflow. We'll cover that off in separate videos talking specifically about how Viavi can help you with your overall workflow. What we want to do here, what you may want to do with the OLTS in this case is that we've saved end face inspection results on both the remote unit as well as the local unit. And because all our reporting is done by the local unit, the first step that we need to take is we need to transfer those end face inspection results from the remote to the local. And we do that by taking the two units, we connect up by USB between the two units using the supplied USB cord. And once we have our USB cable connected, we go into our screen here and into data storage, and we have import inspection results. Imports inspection results from other unit. You tap on that, and it gives you a fail because I've got the cord connected up backwards. So when I connect the cord up the proper way, want to start that over again, or
Yeah.
yes?
While we're at it, can we shut that laptop? It's throwing a little bit of a shadow there.
So I also think I like how you introduced the multiple ways of reporting,
Yeah.
but it actually it took a minute, and you could probably do it a little bit faster.
Quicker.
I like that it was there.
Yeah, okay. Hold on. Let's get that back to.
Good?
Yeah.
Take two.
This is the fifth video for the OLTS 85, and in this we're going to cover off how you can get test results off of the instrument. Viavi gives you some options as to how to get test results reported. One is just basic reporting, which is using FiberCheck Pro, which is what I'll start with. And then we also have test data management, where you can import results and search, you can filter, and you can change some administrative things like labels, and that's with JReporter that I'll also cover. The third is full workflow, which is Certify, which is our StrataSync cloud-based workflow that we have, where you can create a configuration in the cloud, push it down through a mobile to the instrument, and then have the test results flow back up into the cloud. And that will be covered off in some separate videos. So FiberCheck Pro that we're running here on the laptop, we have a USB cable connected. It's supplied with the kits from the instrument. And when I've got FiberCheck Pro running, I'm just going to plug in my USB into my laptop. It recognizes the instrument, and it recognizes that it has Viavi Rocks project, which is the one that we were working on, and you can see that on the screen here, which is the project we were in. So I click on Viavi Rocks. I can see that it's got 2 Tier 1 records, and I then click on, I set up where I want that to go, so it's going to my desktop, and I say Import Project, and it then shows me that it's importing all these different test results. Once all the test results have been imported, and you can see it gives you a tracking, 5 inspection reports and 2 Tier 1 records. I then click on OK, and it will then show me these results. So here I have my Fiber ID 3, and this is my report that shows all the information. It shows me the date and time, it shows me my limit, it shows me my length measurement, it shows me my limits, it shows me my 850 and 1300 results, that everything passed, and it shows me my reference levels, my refractive index, etc. So full report, I can then sign it, give it to my customer, and get paid for the job that I was on. So that's using FiberCheck Pro, and if you just want to simply generate PDF or HTML reports, FiberCheck Pro is your best option. If, on the other hand, you want to do test data management, that's where we start to run JReporter. So I launch JReporter. I'm still connected up through my USB cable. And then I have a new project created here, and I'm just going to go import, and I'm going to import from other devices, which is the OLTS 85. I click on that, gives me the choice again. Viavi Rocks is the project I want. I'm going to import that selected project, and I get an error. So with JReporter, which is our test data management software, you connect up through USB to the instrument, just as we did with FiberCheck Pro, and then we, under Import, select Other Devices, OLTS 85, and then we choose the project, in this case Viavi Rocks, and we click on Import Selected. It brings in the test results. In this case, I've got a project called Viavi, and I've got a site called Viavi Rocks, and then I have my fiber, my 2 test results, which is all that I had, very small little project. So if I right click on one of those results, I can then rename the cable label, the operator. I can replace the cable label and operator name. I could select more than one. In this case, I've just selected one. I can delete things. I can look at properties, etc. And so that's what we mean by test data management. You can change the way that you filter or sort. And then what you're able to do is you're able to export to PDF, say a detailed report, and you can have all results, and you save that to a location. I'm just going to put this on my desktop, save it, and then a PDF report is generated, and you can see as I scroll through, you see the multiple pages for each test result, and it's got all the information, just as you saw with JReporter. But in this case, I'm able to manage my data, my test data within JReporter first before I generate the PDF. And that's it. Thank you very much. There are many resources available for the OLTS 85 in addition to these quick tip videos.